Hello everyone, and welcome to our 6.5 lesson on inequalities within a triangle. And our warm-up question today is, do you prefer white holiday lights, or do you prefer multi-color holiday lights? So if you're watching online and you weren't in here in class today, comment your answer below. And if you're in person, then go ahead and share that with your neighbor. I like the classic white lights. I just feel like I can add color with ornaments when I'm decorating. So I just love the classic white lights. All right, so here's our lesson for today. After we have done our Desmos activity in class, you probably already know most of these ideas. You probably figured them out and discovered them on your own. But today we're looking at inequalities within a triangle. So remember, inequality means that instead of saying that things are going to be equal to each other, we might be saying that something is less than or equal to, greater than or equal to. So these are our inequality symbols. Kind of looks like the Pac-Man. So we're going to be looking at inequalities within a triangle. And so hopefully what you discovered on the Desmos activity is if we have, so across from angle A, we'll call this side A, across from angle B, we'll call this side B, across from angle C, we'll call this side C. If you have three sides of a triangle, which of course you always do, it says that the sum of the lengths, so if you add two lengths of any two sides of a triangle together, it's always going to be greater than, so that's going to be this symbol, it's always going to be greater than the third side. So I kind of remember this theorem by saying 2 is greater than 1, which is a true statement. If you add any two of the sides together, it's going to be greater than that one side. And so if we're doing this with letters, side A, how does that compare to the other two? Well, if I add side B plus side C together, it has to be greater than A. Okay, let's do that for B. Here's side B. That means that A plus C has to be greater than B. And then here's side C. That means that A plus B has to be greater than C. So of these three, the other two should always add up to more than that third side. 2 is greater than 1. I kind of think about this like, especially if you weren't here for the Desmos activity, whenever you want to form a triangle, I think about that third side like the ground. If I want to form a triangle on this ground and I want to actually create a triangle, which means to actually build a tent, I want this tent to actually fully cover this ground, right? So these pieces, these two, need to be, if I were to flatten it out, they need to be longer than this green amount so that it fully covers it. If I were to flatten this out right now, it would be, those two green pieces would be greater than that green side. But let me show you another example. Let's say here's my ground. If I were to create one piece of the tent here and one piece of the tent here, that doesn't actually create a tent. That fabric might cover the ground, but I can't sleep in it, so that is not a triangle. So if it's equal to, it's not enough, if those pieces are equal. And then there also might be a situation where you have the ground and part of the tent goes up to here, and then here's the fabric, it only goes to here. No matter what, we'll never be able to connect those two pieces. And so that would not form a triangle. So those two have to be greater than the one. That's what I mean when I say cover the spread. We want those two pieces to be longer than that third side. And so we really only have to check the longest side, make sure that the two smaller pieces add up to the longest, because if that's true, the others will follow. Okay? So the first thing you're going to do is it says determine if the following side lengths could form a triangle, yes or no. So I think when I was in high school, that I used to just assume that teachers would take any old triangle and just smack numbers on it. Like we'll just slap a 3 here, we'll slap a 5 here, we'll slap an 8 here. That actually, those 3 could not form a triangle. Because if I were to smush those, that would be from here to here would be 3, from here to here would be 5. That doesn't form a triangle. As soon as I open it up, that would not create these 3 pieces. So I would actually have to make this more. I'd have to make this like 6 in order for this to work. So there's a certain range of values that works for triangles, and we're going to get into that today. So we can't just slap random numbers. We have to make sure that those numbers are logical and can actually form the triangle. So how we do that is we look at the largest, and we say, okay, do the two smaller numbers cover that spread? Because if they do, we don't have to check any of the other pieces. So here's what we're checking. Do 8 plus 17, in fact, add up to be greater than 24? If so, it's a yes. If not, it's a no, okay? 8 plus 17 is 25. 25 is, in fact, greater than 24. That's a true statement. Since that's a true statement, we're going to say yes. It says to fill in Y for yes. Those 3 pieces could be a triangle. Okay, let's do that again. Here is my greatest piece. So we're going to check to see if 25 and 27, do they in fact add up to more than 35? I'm sorry, 25 and 12. 25 and 12. I don't know where I'm looking here, guys. 25 and 12. 25 and 12 is 37. So is 37 in fact more than 35? That is also a yes. That is a yes. Those pieces can form triangles, those legs. What happens when we get to 6, 8, and 14? Well, here's my longest side. So we need to see, do 6 and 8 cover the spread? So is 6 plus 8 greater than 14? No, 6 plus 8 is going to be 14, and 14 is not greater than 14. That's false. That's equal to, and so these could not form a triangle. These could not form a triangle. If I were to draw this out, we'd have the third side would be 14. From here to here would be 6. This would be 8. While that covers the ground, that meets it, it does not form the triangle. As soon as I were to open up those legs to make a tent, they would no longer reach each other. So it can't be equal to, it has to be greater than. Okay? All right, let's look at this. Kind of start thinking through this. 3 plus 3, is that going to cover the spread? 3 plus 3, is that greater than 7? 3 plus 3 is 6, which is not greater than 7. That is a false statement. So these three values cannot form a triangle. So far we've had 2 yeses and 2 nos. At this point, I want you to pause the video and see how you do on these. Try them on your own and then click play and see how you did. So what is my largest piece? I always look for my largest piece first. So do 37 and 42. Those add up to greater than 52. That is going to be 79. So 79 is in fact more than 52. So that's going to be a green check mark, which means yes, these can form a triangle. Okay. And then last but not least, we've got 24 is my largest piece. So do 12 and 11, those side lengths, do those cover the spread or not cover the spread? Let's see. That's 23, which is not greater than 24. That's a false statement, and so we would put no. So we had 1 yes and 1 no. All right. So what we've been given 3 pieces for this previous section. Now they're going to give you 2 pieces, and they want you to determine a range of possible lengths for the third side. So I know that sometimes when you're driving on the interstate, they tell you, hey, you need to be going faster than 40, but you also need to be going slower than 70, right? Like you can be going anywhere between 40 and 70 is a good speed you can't be pulled over for, but outside of that range, you could get pulled over and be given a ticket. So that's what we're doing here, determining a range for a third side of a triangle so that I know what values I can pick from and what values I cannot choose, okay? And so to do this, what we're gonna do is we're gonna set up an inequality range. We're going to say, okay, that third value, the x, has to be greater than a but smaller than b, where a is going to be the difference between the two. Remember that difference is where you subtract. And then b is going to be the sum of the 2 legs. Remember that sum is where you add them together. So sum means add. Okay, so we are given 2 side lengths, 14 and 22. And so for 14 and 22, what we need to do is determine what is a range for the third side. Unfortunately, we don't know for that third side. Is that going to be smaller than 14? Is that third side going to be between 14 and 22? Or is that third side going to be greater than 22? And that's why we need a range of these values, because we don't know what we're designing here. And so to do that, what we're going to do is we're going to get a by doing 22 minus 14, and we're going to get our upper range by doing 22 plus 14. Okay? So that would be 22 minus 14. We're going to take the biggest number and subtract the smallest number because these are going to be positive values. When I do that, that's going to give me 8. So x has to be greater than 8, but it has to be smaller than 22 plus 14 is going to be 35. What does this mean? When I am designing a triangle and I've got a side length of 14 and I've got a side length of 22, this third side, the x right here, this third side could be anything that is bigger than 8 but smaller than 35. It can't be equal to 8 because if it were 8, then 14 plus 8 would equal 22, and remember that it has to be greater than. So any numbers between 8 and 35 could be the third side. Any numbers outside of that range would not satisfy this. So like I immediately know 7 would not work as a third side. 37 would not work as a third side. But 17 would because it falls into this range. Falls into this range between 8 and 35 will make the triangle inequality theorem hold true. Okay, I'm going to do a few more and then I'm going to let y'all try some. We find a by doing 31 minus 28. Remember, side lengths are always positive because distance is always positive. That's going to be 3. And then 31 plus 28 is going to be 59. So anything greater than 3, but smaller than 59. Okay. I'm going to start kind of skipping a few of the showing the work and just do it in my head. So 11 minus 3 is 8. That's for that lower range. 3 plus 11 is 14. So that would be the range for the side, the third side of a triangle with a side length of 3 and 11. All right, 19 and 45. Of course, 45 minus 19 is going to be 26. And then 45 plus 19 is going to be, let me make sure, 64, that's what I thought. So if you can't do that in your head, you could always go 45 plus 20 and then minus 1, okay? So anything greater than 26 but smaller than 64. And then try these two on your own and then click play to see how you did. My range here would be 12 to 15 plus 27 would be 42. And then my range here, 45 minus 9 is going to be 36, racing against the clock here, y'all. And then 45 plus 9, and my upper range is 54. So any side length that is greater than 36 but smaller than 54 could be the third side for a triangle with side lengths already given of 45 and 9. And then here's the answer to the other one. Okay, so that's ranges of values, ranges of values. And then the rest of this can be summed up by saying big side goes across from the big angle, small side goes across from the small angle, and reversed. So ordering sides and angles in a triangle. The sides of a triangle can be put in order by comparing the angles. So the smallest side is always going to fall across from the smallest angle. So smallest side is always across from the smallest angle. Which makes sense because when you close up an angle, the distance between those two rays gets smaller. The largest side is always opposite the largest angle. Okay, so why does this help us? Because it wants us to list the side lengths from least to greatest in this first example. But unfortunately, in example 1, we only have angles. We have nothing about sides. So without knowing anything about their sides, we can find this third angle. You need to have all three before you start comparing them. So 180 minus 103 minus 42. I take my budget of 180 for a triangle and subtract off what I've already spent. So that's going to be a total of 35 degrees left. So make sure you have all three angles, and now we can compare them. So what is the smallest side length going to be? Well, it's going to be across from the smallest angle. Here's the smallest angle. That means that side ED must be the shortest. Even though I don't know what its value is, side ED is the shortest in this triangle. Okay, so the medium length, 42, is the medium angle. So the medium side length is going to be DF. Okay, DF, it's just across from it. This was across from this one. And then the largest side, you can kind of tell in the picture, is across from the obtuse angle, 103, EF. So we could tell just by looking at the numbers, the angle degree measures, what the side lengths would be. I don't know exactly what they are, but I can put them in order from least to greatest. Okay. All right, if in doubt, draw it out. If you don't have a picture and you can't do this in your head, you can always draw a picture. This is just a rough sketch, doesn't have to be perfect. In triangle JKL, angle J is 62 degrees. Angle K is 57 degrees. So how do you find angle L? You're going to do 180 minus 57 minus 62, because we always need to have all three before we compare, and that gives me 61. Why does that help me put them in order from least to greatest? Because now I can just look at this and see that the smallest angle is 57. So the other two letters, that's going to be JL. JL. The medium angle is 61, so the medium side length is going to be KJ. You could write KJ or JK. And then our longest side is going to be this last one. This last one is 62, is the biggest angle, so the biggest side will fall across from that, which will be KL. That's from least to greatest. We could also reverse this order and go from greatest to least, which of course would just allow these values to switch. They would just go in the reverse order. All right, and then we have our last part, which just says ordering angles. The angles of a triangle can also be put in order by comparing the sides. So again, the smallest angle is going to be opposite the smallest side. And then the largest angle is going to be across from the largest side. So in this first example, it says list the angles again from least to greatest. I don't know anything about these angles. I don't know angle A, I don't know angle B, and I don't know angle C. But I do know that between 7, 10, and 13, 7 is the smallest. And so if I'm going from least to greatest, the angle across from that will be the smallest. So it would go angle A, 7, and then for comparison, BAB is 10, so the angle across from that is angle C. And then the longest side on this picture is 13, so B falls across from that, so that would be angle B. So we go angle A, angle C, and then angle B would be the list of these angles from least to greatest. All right, last but not least, we have a triangle. So again, if in doubt, draw it out. In triangle XYZ, again, this is just a rough sketch, 9.3, YZ is 7.6, and then XZ is 8.05. That is very, very specific, so let's go through and find the angles in order from least to greatest. So if I want the smallest angle, I'm going to go look at the smallest side, which is YZ. So across from that, the angle opening up to that would be X. Then 8.05 is the medium, so that'd be angle Y, which leaves 9.3 as the longest side, which means the angle Z would be the one that is opening up to that. So angle X, angle Y, angle Z. And then y'all's assignment is on the back for homework, just to practice.